Do you want to find interesting tech discussion chat or a teammate to play with? Join Hardware Lab Discord server using the link in the description. RDNA 2 was released around 2 years ago and became an industrial standard for a lot of gaming and not only devices. Besides being in the heart of a really successful Radeon RX 6000 cards, RDNA 2 is used in PS5, Xbox Series and Steam Deck consoles. Even Tesla's entertainment system is using RDNA 2. However, from the general design point of view, RDNA 2 is very close to its predecessor, RDNA 1, which changes a lot from the GCN GPUs era. This video's main goal is to compare RDNA 1 and 2, overview the main differences between them and do some fair testing. Hello and welcome back to Hardware Lab. At first glance, RDNA 1 and 2 compute units have a lot in common, and we will come back to that later. AMD continuously uses their approach to async computing with 4 async engines. It helps to manage the priority levels for graphics and computing tasks, since computing tasks can be pretty latency sensitive. This design was used at first even in Radeon HD 7000 cards. However, it was that broken back in the days that for now HD 7000 series has the system shut it down on the driver level. The shader processor itself, unlike Nvidia's, operates with a 64-bit floating point instructions, and AMD has 64 of them per one compute unit. The main differences between RDNA 1 and 2 are hidden not in logical structures but in the memory, subsystems and supported technologies. One of the most ambitious innovations of RDNA 2 architecture is a new cache hierarchy. Multiple low-level cache structures are connected to a few separate buffers of L1 cache, which are 128 KB per shader engine. Then there is a 4 MB buffer of L2 across the GPU and a new L3 cache structure called Infinity Cache that reaches up to 128 MB buffer size in top-tier cards. This new additional cache level with a massive size and fast bandwidth works as another step between normal L2 and much slower GDDR6, increasing the effective bandwidth to super impressive 1664 GB per second according to AMD. In comparison, the same card structure without extra cache layer would have just a normal GDDR6 bandwidth of 512 GB per second. If we compare that to the fastest memory subsystem in gamers' cards that was used in Radeon 7, we would see that even a super expensive top-tier HBM2 memory subsystem could reach only a 1 TB speed back in the days. Of course, the new cache level cannot boost the speed of the whole VRAM buffer, so this efficiency counting method has limitations and cannot represent the whole situation, but the numbers are still the same. Moreover, despite using the same 7nm technology, architectural optimization let AMD improve the power efficiency up to 54%. Better power efficiency means wider GPU models possibility. This is the reason why there are top-tier GPUs based on RDNA 2 in the market, and the overall performance improvement between top-tier RDNA 1 RX 5700 XT and top-tier RDNA 2 RX 6900 XT is at least 100%. Speaking of technologies that are supported by RDNA 2, the major improvement is a real-time ray tracing hardware acceleration support that makes the ray tracing calculations 10 times faster. Each RDNA 2 CU has one ray accelerator unit for that purpose. Furthermore, there is a hardware support for a variable rate shading technology that requires the GPU to output the image with different resolutions on different parts of the screen. Along with RT and VRS, there's also a mesh shader support and direct storage, which we overviewed already in the Xbox Series S technical analysis. Furthermore, RDNA 2 GPUs are the first generation of GPUs that are completely capable of boosting from resizable bar technology. This technology changes the standard way of GPU data providing via the PCI Express slot. The standard PCI technology limits the amount of data in GPU memory that is controlled directly by CPU, which of course causes the additional latency. With rebar, or as AMD called this approach Smart Access Memory, the whole VRAM buffer controlled by CPU is not a problem anymore. And even putting that out of the brackets, AMD promises the 30% frequency increase using the same power. The clocks well above 2 GHz is now possible with RDNA 2, some of the models reaching at 27 to 2900 MHz when overclocked. However, there are no promises of IPC advantages officially posted by AMD, which is not a good sign if you remember almost similar CU structures of RDNA 1 and 2. It seems like RDNA 2 is designed more around power efficiency and high clocks, rather than actual IPC improvement. It's very good that AMD's 6000 Gen Radeon RX 6700 XT has the exact same CUs amount and the numbers of ROPs and TMUs as previous Gen RX 5700 XT, so they are quite nice cards to compare, to find the impact of RDNA 2 improvements. The only thing that differs between these cards is of course the memory subsystem. Firstly, RX 5700 XT's VRAM buffer is a pretty small 8GB one, so in all of our tests we were trying to use a VRAM optimized settings for this VRAM amount, not to cause any issues on this card. Secondly, technically the RX 6700 XT's VRAM bandwidth is lower, 384GB per second versus 448GB per second. But in fact, the new approach to memory subsystem mentioned before makes these numbers really incomparable. In the test section, apart from simply testing these cards against each other, we will take a closer look at IPC difference. So one of the testing modes here will be for a 6700 XT using the 5700 XT's clocks. Moreover, both of the cards in their stock conditions will use the unlimited TDP, for them to stay at their stock clocks as frequently as possible. Separately, we will also check the power efficiency and ray tracing benefits of a newer version of RDNA. So how are things going? Let's find out. Wow, the results in Dirt 4 look really disappointing. Of course, the power efficiency benefit on the RDNA 2 side is huge, but what's wrong with actual performance? There's an IPC decrease, and even the stock 6700 XT is hardly overperforming the previous gen card. Talking about power efficiency, RX 6700 XT consumes less power while delivering more performance. We are sorry for the performance stats bug in Assassin's Creed Odyssey. We tried to restart the game a few times and do whatever we can to fix it, but it is how it is. Talking about results, there is almost no visible IPC advantage here as well. However, at least there is no disadvantage, and the stock clock 6700 XT is noticeably faster. The overall performance in this game is really high on all of the GPUs due to easy to run TIA implementation, and the game being not hardware demanding in general. And again, no IPC improvement. Despite this game was designed especially to demonstrate some of the RDNA 2 next-gen features, and despite using a different engine from Dirt 4 and a superior API, IPC is still better on the RDNA 1 side, and the performance advantage on stock 6700 XT is not huge. By the way, just take a look at 5700 XT's power consumption. It's almost equal to what 6900 XT can consume, a crazy number. Assassin's Creed Valhalla also seemed as a very RDNA 2 optimized game, but in fact, downclocked 6700 XT is still not faster than RDNA 1 GPU. However, stock 6700 XT performance advantage is fine. One more game with the disadvantage of IPC on RDNA 2 side. But in comparison to the previous Life is Strange game, True Colors is a lot more technical advanced and uses a way better designed DirectX 12 instead of 11. Pretty disappointing result. Forza Horizon 5 is another well-optimized game, and it's great to see how well it runs on RX 5700 XT. And again, there is no IPC improvement despite this game was developed first of all for Xbox Series systems with RDNA 2 in mind. Remaster of the Spider-Man was originally released only on PS5, and only after that ported on PC, of course with RDNA 2 in mind as well. The IPC boost here is still almost meaningless. Talking about stock 6700 XT performance, it can be slightly CPU limited, since we are using the Ryzen 5 3600 in our test bench, and Spider-Man is very CPU demanding, so keep that in mind. Cyberpunk, on the other hand, shows some noticeable IPC improvements on RDNA 2. Finally, we found a game that can use the advantage pretty well. And what feels especially good about this game is that RX 6700 XT's power efficiency here is better for over 60%. Not massive, but definitely noticeable IPC improvement can be found in recently released Saints Row as well. And combining with core clock advantage, RDNA 2 provides a huge performance improvement. Lastly, Red Dead Redemption 2 doesn't show any IPC improvements as well. It is a very technically polished game and it was the first sign of cross-gen back in the days, but obviously this game has been released long before RDNA 2. So to conclude the main test, I would say it is obvious now that RDNA 2's IPC advantage is only visible in some newer games, and there are still not many of them. The old DirectX 11 games are even more likely to show the disadvantage of RDNA 2 in terms of IPC. Even the newer games in that series, but based on the same engine, are more likely to prefer RDNA 1 chip structure. Speaking of the cross-gen and current-gen titles that are definitely made for pushing modern hardware to its limits, only a few games like Saints Row and Cyberpunk 2077 prefer the new chip design. However, when the high frequency and RDNA 2 IPC advantage combines, the magic happens and 6700 XT becomes a really much stronger card than RX 5700 XT. Moreover, I would also like to touch slightly on power efficiency and consumption here. Based on our main testing stocks, RX 6700 XT shows a massive FPS per watt improvement that can reach even 65%. This number can vary from one game to another massively, so there is no such thing as a constant improvement. But all the numbers are impressive, keeping in mind that the technology stays at the same 7nm TSMC. But remember, the purpose of this main test wasn't to compare the power efficiency. For that, we will undervolt the 5700 XT that will leave us with a slight clock loss around 50 MHz, but we will massively turn down the TDP. After that, we will lock the 6700 XT at the same TDP and reduce the voltage as well, to see what part of this massive performance per watt improvement is just about 5700 XT being inefficient out of the box by trying to reach the peak stock clock, and to see how this number scales on RDNA 2. RX 6700 XT's clock in Cyberpunk, when we are tuned and limited to undervolt 5700 XT's TDP, were actually higher than the stock clocks, so the performance advantage in this game is of course crucial. However, 65% efficiency improvement that was here previously now became only 38%. One more game where 6700 XT in this test runs actually faster than the stock card, so no surprise that power efficiency advantage here is not that high as well. But keep in mind that 6700 XT here is technically a bit overclocked and the performance is a lot higher. Even higher performance difference between 6700 and 5700 with the same TDP can be seen in Saints Row, while the power efficiency benefit is still fine.
You search, you find. Let's press, go through it. You're numb, you're belted. Don't worry, stand by.
Spider-Man results are quite unimpressive here, since the performance per watt improvement is really small, but probably it's connected to the CPU limitation factor of 6700 XT test. Not that big performance difference is also connected to this factor. When both of the cards are undervolted, the power efficiency improvement doesn't look that good anymore. However, the performance uplift is still nice to see. The thing here is, to reach the undervolted RX 5700 XT's power limit, in a few games we were technically overclocking the 6700 XT, so there is nothing wrong with the numbers being worse in this specific test. But I have also promised to overview something about one of the most impressive next-gen visual technologies, ray tracing. The RX 5700 XT, as mentioned before, doesn't have the hardware-accelerated RT support, while there is no software solution. So in further RT tests, 5700 XT will be running without RT effects, and on 6700 XT they will be turned on. Let's check if 6700 XT with a much more advanced ray tracing approach to 3D graphics can actually overperform the 5700 XT that renders just a rasterized image. Saints Row results surprise us a lot. Using the next-gen high-quality ray tracing AO, RX 6700 XT is still overperforming the 5700 XT. Looks like something worth upgrading, really. In Spider-Man Remastered, the results are not that great as they were in Saints Row, since RT effects here are much more demanding. However, the game is completely playable with RT on 6700 XT and not losing too much to a 5700 XT, with a stock cube map of reflections. One more interesting result is Dirt 5, because here the performance on 6700 XT can be higher or slower depending on how many vehicles are there on the screen, and other scenes conditions that stand for amount of ray tracing calculations. Overall, the 6700 XT's performance here with RT local shadows was even a bit faster than the 5700 XT's performance with standard shadow maps, so another great result. Cyberpunk shows the same behavior as Dirt 5, despite RT effects here are much more demanding, so we can clearly see that more ray tracing reflections on the screen means less chances for the 6700 XT to overperform 5700 XT. Overall, 6700 XT here was a bit slower, but keeping in mind it uses fully ray tracing reflections instead of SSR and cube maps make the result impressive. And by the way, it must be mentioned that we also used an FSR 2.1 modification in this game, and set it to a balanced preset to get more playable FPS on both of the GPUs. The overall RT test results are very impressive. In many games, RX 6700 XT with turned-on ray tracing effects can be still faster or at least not generally slower than the RX 5700 XT without ray tracing. To sum up, RDNA 2 architecture is really a success for AMD, since in this gen they are able to produce the high-end GPU that can overperform NVIDIA cards for even less price and a better power efficiency. RX 6700 XT is of course a way superior card than the previous gen 5700 XT. Moreover, the testing itself shows that each game really reacts differently to new architectural benefits, increased clock speeds and other technical specs of the hardware. So this proves again that any relative performance statistics and all that stuff just doesn't work. The results differ a lot based on each game's hardware complex usage. Coming back to AMD, they have already announced the RDNA 3 architecture release on the 3rd of November. So if you're interested in PC hardware, this is definitely worth checking out. And as usual, stay up to date with HL.